Okay, in this video, I'm going to introduce the use of the multiple choice questions from our public exam papers. So this is my page of the pgde notes, and you can go to this links below to open my Evernote file about multiple choice questions. So this is my Evernote file. So you can see my collections of past paper 2 questions, and from 2010 to 2018, you can see one big PDF files in this Dropbox. And then the source is actually the public library, so you can get the e-copy directly from the public library. And this is my note explaining the use of these questions. And here the questions collected in different topics. So you can click on each of these to look at the question classified into these topics. For some topics, I produce Desmo activities to show you how this question can be put into the platform of Desmos. You can do the same for some other questions in a similar way. So here I open my notes. This is the Google slide. Okay, so these are the MC questions I select and explain why I would like to use it for the teaching and learning process. So I would like to emphasize that the use of the MC will be more flexible and useful compared with the conventional questions, because even though we tend to spend more time on training the students to practice for the long questions or how to present the work in formal steps. However, the MC questions sometimes more focus on the conceptual understanding and can lead to more flexible discussion, because sometimes we may put aside the formal steps in arriving at the answer. Instead, we focus more on how the student understand individual options and the way they look at it. So there's an implications on the developing concepts rather than just skills for public examination. So therefore, it is part of the concepts of formative assessment and also diagnosis of the misconceptions. And that means in this way, they are turned into learning tasks in the classroom. It's not simply practice for public exam. We can use it in many different ways with or without technology. So that means it can be just simple paper form to use in the classroom, or it can be turned into the electronic platform that we'll try to introduce to you, or some other platform that is convenient. So overall, it is leading to your understanding of the task design and developing of questioning when you try to make use of this kind of MC question or try to adapt them. So similar discussions can be found in Greg Barton's website, while he also used a lot of diagnostic questions. So you can see a lot of this and also his ways of encouraging the use of it in the teaching. So these are extract from some of the example from Greg Barton's website. So for example, these are the questions, very typical in MC, but when you use it in a classroom discussion, you can use it in very flexible way. Let's say this question can be turned into this form when I cover the given values. Here, when I cover the given values, I can ask the student which of this answer can be obtained, right? If I set different values here, then it becomes a very open question. So that means the same question can be an ordinary MC question or turned into an open question. So another example, this one is asking the student what's the next step. Okay, so you can show them the answer and ask them to choose, but you can also ask them to work out the answer first in their own way without showing them these options, right? Just ask them what would be their first step and then show them the answer, then they can choose. The difference is that they start from their own methods without paying attention to the given options, okay? So the way just a little bit change in the presentations will already lead to different kinds of process and discussion. Another good source would be Dylan Williams' book. I introduced somewhere else. You can find it in part of his book. He mentioned the kind of use of the multiple choice questions and for discussions and different ways of using it. or different types of MC questions. Some are for multiple correct answer. That means there can be more than one correct answers, right? Which will be more suitable for initiating or encouraging discussions in the classroom. Now we come to the examples in our MC papers, right? So these are selected from the topic equations of straight lines, right? Some of these are very similar to ordinary conventional paper questions. For example, this one, if you don't give them the options, it will be similar to other standard long question. The student will probably work out the answer step by step according to the standard procedures. But if you give them the options, and they will try it or do it in another way. For example, in this one, if they quickly recognize which lines should be parallel just by looking at the first two coefficients, then they will already see that only D and E can be the choice. Then you just substitute this point into one of this equation, you can quickly recognize which is the required equation. Now, this kind of thinking sometimes can be considered as a trick or shortcut for answering MC question, right? Some teachers may emphasize in this way. However, putting aside whether it's a trick or not, it is actually a process of emphasizing the concept behind the topic, this mathematical content, and also the flexibility of thinking, okay? Because it requires the student to pay attention to different properties, characteristics, and relation, and make the best connection to answer the question. So this kind of training is not that usually emphasized in classroom practice of textbook standardized questions, right? And unfortunately, when you turn to the MC exam, sometimes we just consider it as a shortcut or a trick that we specially use to answer exam question. Then the student may assume that this is nothing to do with the learning process, right? It is just an extra or additional skills or techniques that they have to learn, right? However, if you combine with the ordinary learning process, then the student will appreciate that this is part of their concept understanding. Now, another types of question will be even more suitable for this kind of discussion because it is obviously not asking students to do any calculation step by step. Just like this one, it is about making choices, comparing options, looking at the characteristics, or even sometimes to deal with the symbols in an abstract ways. And for this question, it can be quite difficult. But in the discussion process, it's not necessary to focus on what is the final answer. It can be broken down into different parts to let the students different opportunity to talk about what they see and think in this process. For example, the question can be changed into which two slopes are easier to compare, and also which two slopes are difficult to compare from the student's point of view. Then they can review their understandings of slopes and symbols when doing so without too much worries about which is the final correct answer. So this is another similar question, but even more difficult. And it sometimes comes in this kind of form, asking the student to judge whether each of the statement is right or wrong. And so it requires a lot of detailed and sophisticated thinking and reasoning. So actually, this is a very good process for developing reasoning, although it is also quite a challenging question, right? But if you put more attention in the reasoning itself, then perhaps more students can benefit from this kind of discussions and questions. And meanwhile, you can see that in this figure, it's quite ambiguous because the student have to decide which geometric feature should they pay attention to, and also to what extent they assume that certain information is given. For example, it's not sure whether this line is considered to be always steeper than the other, or it is supposed to make use of the x-intercept, right, in this question. So to most students, this may be rather arbitrary and ambiguous, right? But it can actually lead to also open discussion if you allow the student to talk about what they see, what they assumed, or how they think the general case could be. So apart from just giving the correct answer, that means there are also opportunity for a lot of different kind of discussion and conceptual understanding. So I further provide some other examples apart from the equations of straight lines examples. So this one is from the TSA, the junior secondary levels exam. And so that this is also a kind of question that can be used for discussion in the classroom, because it's about asking a student to analyze the step. It's not just about solving it step by step. Another one, also from the TSA. So this one requires the students to compare the expressions and quickly find out which ones are equivalent. So it is different from formal proof of identity. So it does not require very detailed steps in proving identity, but it emphasizes the very fundamental concepts of equivalence and understanding intuitively how the expressions can be transformed. Another one, also from the TSA, this one, of course, requires students to use the formula about midpoint, but at the same time, it does not emphasize too much on the actual calculations. Rather, it encourages and reading of the expressions carefully, right? So that's another kind of skills that not usually practiced in classroom or textbook exercises. So there are many other examples I put in this file to draw your attention to some special features of the MC question. Once you pick up some useful ideas, then you can turn it into learning tools or tasks in the classroom. Now, the second part, I move on to talk about how this question can be presented in the Desmos platform. So this is the site of the Desmos Teachers platform, and you can log in with my account here. This is my teacher's account, which I create to share activity with other teachers. And you can use my password to log in with this teacher's account, so that you can also see the students' response I have collected through different trials in the classroom. And so this is some screenshots from the Desmos activities. So you will later see how this question can be presented in the Desmos platform, and ask the student to answer and then collect the answers quickly. It also comes in different forms, particularly when it is related to equations and graph, then it can be easily created in the Desmos platform in a variety of ways. So there are also other topics that you can also consider using the Desmos activity platform. Now I turn directly to the Desmos platform here to show you more details. So this is the topic about coordinate geometry and lines, and a set of questions are put in the Desmos activity platform. So you can click on this to open it in the Desmos website. So this is the teacher's view. If you use your own teacher's account, you can still access this page to see the questions, right? But to see my students' answer, you have to log in with the account I have given you. First of all, we look at the students' question. This is the students' preview. So these are the questions. The student can answer this by choosing the options. So once they choose, okay, then this can be submitted. So these are also questions that I quickly put in the Desmos platform. Now this is another question. If you click on the answer, then another prompt will ask you to explain your thinking. This is optional, but we can encourage a student to write down something about their way of making decision or what they see in the graph, in the diagram, and so on. So these response can also be collected and even shared with the other student through the platform. So this is another example. So this is a question previously based on the public exam question that I just showed you. There are 4 lines, and then we ask them to compare which slopes is bigger than the other. So different choices. And you can apply. That means in this case, you can select more than one correct answer. There can be more than one correct answer to be taken. So it will be more flexible. In this way, the students can choose different answer depending on certain and what they can easily compare, and then discuss about this results later. This one, the choices is given as a figure, as a picture for them to choose. So this is also pictures created in the Desmos so that the student can easily choose the answer. And at the end, we can also incorporate other kind of questions. So the Desmo platform is very powerful. So although I show you mainly the multiple choice question in the previous examples, however, the platform itself also allows you to create many other kind of questions. Some are even dynamic and interactive, right? Therefore, it provides a lot of different means for the student to interact, respond, and also allow us to gather their responses for further discussion and sharing. Just like this one, we ask the student to match the graph with the slope, right? So the students can try to put together this slope and the graph, for example, into this way, and you can also amend it quickly if you make any mistake, or you can hide them so that you can have more space for this for the work here on the screen. So they can be easily manipulated in iPad or the computer. So you can enlarge it to see the details. So these are the cards that you can make so that you can ask the student to match them. This is another example. This question is more abstract and it's also open-ended because when you match with the given slope, you'll find that it depends on which one you assume as M. If you take it as M, then the other three can be matched accordingly with the other three graphs. Similarly, you can call this, you can say that this slope has a slope M, and then the other one will also have an own way of matching with the other three graphs. So that means it is, to a certain extent, is a rather open question and invite the student to think about the meaning of the symbols. So these are the preview. So that means if the student log in in the platform, then they can answer this question and then submit their answer. As a teacher, you can see the result. Now, how the students can log in, and you can see that this is one trial that I have asked some teachers to go through, and you can see this. This is click this link to open the dashboard. So these are collections of the students' work, and if you look at this, let me see. So we can reactivate this activity. So actually, when you open the activity, the students can go to this website and then enter this code. Just put in their name, they can already start working. So these are the answers that we collect, right? So this is the first question. Just simply ask the student to pick one answer. And if you look at the teacher's view, then you can see the summary of the answers. So you can collect this answer before the lesson. Just give the student the link so that they can answer it at home, and then you can try to analyze their answers in order to discuss it in the classroom. Sometimes if you really have enough time in the classroom, you can also let the student answer the question during the lesson and then discuss them directly. So this is the second questions. So we ask the students to think about which line is the green line. So I make use of the color so that the question can be simpler. But at the same time, actually, I encourage the student to look at the pattern because I draw 4 lines, so which is actually related to each other. And the form, you can see the form here. I invite the student to pay attention to the sign and think about in what way this varying of the parameters will change the graph. So it is more than just following the standard technique or skills in finding equations or understanding this or checking the slope and intercept. Right? It is more about explaining relations or try to pay attention to the coefficients in a more systematic way. So this kind of discussion is different from, that's why I say this it's different from the ordinary textbook exercises. Actually, as a follow-up, you can ask the student to match all the equation with individual lines. Although I only ask for the green line, actually the other equations are corresponding to lines of other color, so that some other student can pick the extra challenge of matching all the line and knowing how overall a pattern can be created by just varying the coefficients. Now, in answering this question, they are invited to give some explanations or descriptions of the work. So if you check the teacher's page, this is the summary of the student's work. Okay, and so 24 students pick the second answer. And below, you can also see some of the description. Some students try to put down the description, and you can actually select some of them for further discussion. For example, you can pick this one, and this is a button for you to collect the students' work. So in the snapshot, later in the snapshot view, you can see some captured answers from the student for your easy comparison later on. So you can discuss with the whole class which one, for example, which explanation or which description do you think is more relevant, right? Something like this. You can make use of this answer. So this is a very flexible platform. Now, similarly, the other questions are designed in more or less the same way. So this one is about explaining the slopes, explaining the comparison of the slopes. So if you look at the teacher's page, there can be more than one answer. Right? So you can see if you click on the answer key, and you can see which one is correct. And the later part to work, for example, this one, we ask the student to decide where is the point R so that PR is equal to RQ. In this figure, R can be moved. So apart from just choosing the answer, we can also ask the student to use a figure to explore or even to show us the answer, right, where they really put the point R. So in order to better know the choices, okay? So these are the point given by the student. So you put it aside, these are individual graph, and you put it together, you can see most of the students can put the point in the positions that we point to. So these are extra features that you can make use of in answering these questions. Finally, this is the card sorting task. And if you look at the teacher's page, then you can see who have the green one represent the correct answer. So this you can see this student have given the correct answer. So you can pick up the answer key, or you can hide the answer key for the time being and ask the student to check whether these answers are correct or not. And other picture shows some wrong answers. So these are wrong answers. So you can have a quick view together. And for the overview, then you can see what are the most common incorrect groups the students have made, or most incorrect cards are common incorrect cards. You can show more. Then the system will check for you. So which pair seems to be more likely to be wrong, or which card seems to be quite likely to be wrong. And the last one is an open question. So we do not have particular answer, but you can see the students grouping. whether they are doing the grouping in the same way or not. So these are different grouping provided by the students. Okay, if you go back to the teachers page, then you can see this button, what we call the anonymous button. You can see these names are not the real names, right? So they are randomly generated by the computer, so that you can show the screen directly during the lesson and ask the student to comment on the answer without knowing who give the answer individually. Of course, you can go click on turn on this page and turn off this one so that you can see the real name of the students afterwards. So this is the front page of this teachers activities. So you can find out more from the Desmo platform to understand how to create this task. So which is in general, it is not too difficult, right? Particularly if you are building ordinary multiple choice questions, then it should be quite easy. And you can look at my other examples. In my website, you can see this collection, the Desmos collection. Here, you can find out a few more groups of examples that I have prepared. Right? For example, this is about circle equation, circle geometry. So you can look at this one. This is about circle geometry. And this one is directly captured from the multiple choice questions in the past paper. So I don't have to really draw all the figures on my own, but I can make use of existing question and ask the student to answer it. So you can find out more about the Desmo activities in my homepage. The last link is a link to some recent workshops that I've conducted, including the use of the Desmos. Right? So and you can try to have a look to see whether you can follow these steps suggested to make some simple Desmo activity to use in the classroom.